my name is Nura Ain Zaida binti Zainuddin. My metric number is 183778. We are from group 5 and we are given question, and this is our function fx equal to 2x divided by sec x squared plus 4. First step that we need to do is we need to differentiate the function, and this function differentiate by question rule. So this is u and this is v. When we using the question rule, it will become v du minus u dv divided by v squared. And after we differentiate u and v, and then we insert it into the question rule, and then we get this. We put the v here, and 2x we differentiate become 2, and then this is differentiate of v, and this is u and v squared, and then we expand it, and then we get this. We simplify this, and then we get this. The answer differentiate of function, that function will get 8 divided by sec x squared plus 4 power of 3. Thank you.
Okay, my name is Siti Fatimah Zahra binti Muhammad Harudin. My metric number is 174747. Okay, this is the second step, which is we want to find critical point based on the first derivative test. First derivative test, we got this f prime x equal to 8 over square root x squared plus 4 power of 3. So in critical point there is two things, which is f prime x equal to 0, f prime x does not exist. So in this in this first derivative test, numerator is equal to 0, and when we move the point here, the x does not exist, so there is no critical point in the first derivative test.
Hi, my name is Siti Hajar Nur binti Syahris. My metric number is 172366. So we are going to proceed with the second derivative test. Okay, previously we already done the first derivative test, which is f prime x equal to 8 sec x squared plus 4 to the power of negative 3. We're just changing the form from the previous one. So here we are going to do the second derivative test, f prime x. So we bring the negative 3 times with 8, negative 24, and then write it back to the power of negative 4, because negative 3 minus 1, and then differentiate again inside this, half x squared plus 4 to the power of negative 1, and differentiate this one, x squared, we get 2x. So after we solve this, we get negative 24x over sec x squared plus 4 to the power of 4 times with 1 over sec x squared plus 4. Just changing the form. We can times to sec x squared plus 4. And then finally we get the second derivative test like this. Negative 24x over x squared plus 4 sec to the power of 5. That's it.
Hi, my name is Nurhilda binti Ruslin, metric number 174762. We solve the first derivative test and then second derivative test. From second derivative test, we can get the inflection point. So this is our second derivative test. Negative 24x over square root x squared plus 4 power of 5. We equal to 0, and then we solve this one. Multiple, and then become 0. Negative 24x equal to 0. Inflection point is 0. Oops, sorry. 0. After we got the inflection point, so we can determine the concavity. So as we know the inflection point is 0, 0. So the range is negative infinity to 0, 0, 0, 0 into positive infinity. Then we just substitute. For this one, we choose negative 1, substitute and get positive. So concave upwards, smile. And then 0, 0 is inflection point on it. And then we choose 1 and substitute into f double prime and get negative, so concave down. That's all for the concavity.
Okay, the sixth step is we have to find horizontal asymptote. To find horizontal asymptote, we must use limit x approaches infinity. Using the function, our question, 2x over third x squared plus 4. Okay. To find the horizontal asymptote, the equation must be divided by the highest order of the numerator at the power of x. So the numerator we must divide by the x because denominator the x squared third x squared. So third x squared equal to x. So 2x over x. And the denominator x squared over x squared plus 4 over x squared. So we just cut it off. This one not. So the limit x approaches infinity equal to 2 over third 1 plus 4 over x squared. So we insert infinity into the equation. So 4 over x is equal to 0 and we got 2 over third 1 and we got the answer is plus minus 2. The horizontal asymptote is plus minus 2.
Hi, Assalamualaikum. My name is Nur Syazwani binti Abdul Hamid. My matric number 171911. So let's proceed to the next step. We need to sketching the graph. So the previous shows that we need to find the concavity between the range negative infinity 0, 0, 0 and 0 to the positive infinity. So the range between the negative infinity we get the concave upwards, and then the inflection points we get 0, 0, and then 0 to the positive infinity we get the concave downward. So let's start to sketching the graph. We just put or insert the some numbers inside between this range and also this range by using the equation of the fs for this function. So after we put the value inside, we can get the x and y coordinate, which 2 and 1.5, and also negative 2 and negative 1.5. And then we sketch according to the concave upward and concave downward. Then we get this graph. Okay, so that we just label it the inflection point and also the value of the coordinate. We get the horizontal asymptote between the 2 and also negative 2. So we make sure that this to sketch the graph, we need to make the graph range between the 2 and negative 2 in the y-axis. So this is basically how we get the graph from this function. So that's all for me and also my team. So thank you.
That's all from us.
Thank you.